Hi guys, good afternoon to Oliver, Georgie. Hope you guys are all doing well. I'm just going to give a couple of seconds, about a minute more, just to make sure everybody's in. But hope you guys are all doing well. Hope you are having good A levels so far. Your A levels are going well. And yeah, let me just get more people are joining. So I wish there was a way to just let them join without me having to click each time. But I'm just going to give a couple of seconds. But how are you guys anyway? Hope you guys are all doing well. How was paper one, by the way? How did you guys find paper one? Just gonna, okay. Wow, there's a lot of people today, it seems. Okay, okay. Cool. All right. So let me just admit a few more. Okay, cool. So let's make a start. So before we start, actually, let me just introduce myself. So for those of you that don't know me, my name is Daniel. I'm a GCSE and A-level maths tutor, and I studied maths at university. I graduated in 2018, and I've been tutoring full time. And yeah, I run GCSE classes, A-level classes every week. And yeah, I did an A-level class last week, and I'm sure a lot of you joined and saw it on YouTube. So thank you very much for that, for your feedback. I'm very grateful for it. I'm just looking at the chat to see some messages. Okay, okay. Worried about, missed a lot of questions. Was all right. Didn't like the roller coaster one. Okay, fair enough. Remember with these questions as well, as long as you try some methods, you get some method marks, you'll be okay. But you've got two more papers, so you'll be fine. But yeah, the way the class is going to run today, so the class is going to be mainly based on Edexcel, just due to the fact that Edexcel was the most popular exam board. A lot of students on Edexcel. But with the other exam boards, so for example, AQA, OCR, MEI, there is a lot of overlap, as you know. So if you're not on Edexcel, don't worry, it's still going to be beneficial for you today. And yeah, so you're going to be able to communicate by just dropping a message in the chat. So I'm going to go through some questions. You'll be able to drop some messages in the chat. Now, while I'm going through some questions, guys, I'm going to be asking you, I'm going to be prompting you with questions while I'm going through it, just so I know that you guys are understanding it and it's all making sense. So please make sure to drop messages in the chat. Okay, cool. All right. So what we're gonna do, let me share my screen now and we're gonna make a start. Okay. So what I've done, by the way, I've got some questions based on what hasn't come up in paper one. So that is sigma notation, trig, proof by contradiction, implicit differentiation, binomial expansion, parametric, so on and so forth. So we're gonna go through these together. Now remember what I said, I'm gonna go through it with you guys because I know an hour goes by very quickly based on last week's lesson, could go by very quick. So I'm gonna go through them. While I'm going through them though, I want you guys to be dropping messages in the chat so I know that you guys are understanding. So we're gonna start with this first one here. Put this here. Okay. So let me just drop this here. Okay. So question says for the first part, right? It says show that the sum of r equals 1 to 16 of 3 plus 5r plus 2 to the r is equal to 131,798. Now looking at this one, guys, what are our thoughts on it? So put a 0 if you're looking at this thinking, I have no clue what to do. This is very confusing. And put a 10 if this is super easy. If this comes out 4 marks in the bag. I want you guys to all drop me a number in the chat between 0 and 10. Okay, good. I can see eights, I can see nines, fives, eights. I can see on average about eights and sevens. Cool. All right, so let's make a start. Now, when you're doing this question, the first thing that you need to be aware of what this sigma notation actually represents. So it says we've got the sum of 16 and r equals 1, right? And I'm going to give you an example just for anybody that's a bit unfamiliar, right? If I have this here, let's say I have, for example, I don't know, let's say I don't know, r, right? What this actually means is that I'm going to sum the first 16 terms, right? So it would be 1, right? R equals 1, and then R equals 2, plus 3, plus 4, plus all the way to 15 and 16, yeah? We need to be aware of this. This is very important when you're doing these types of questions. Okay, so now with this one here, we have a couple of things going on here, right? So what we want to do is we want to break it down. Whenever I'm doing these questions with my students, I always say to them, it's kind of like playing a game. You're looking for the patterns that are emerging when you're looking at this. So what I'm going to do is I'm going to write this out again. I've got 16. I've got r is equal to 1. And then it's 3 plus 5r plus 2r, 2 to the power of r. And then this will equal, or according to what I just said, will be 3. The first one will be 3 plus 5. And then r will equal 1, lots of 1. Plus 2 to the 1. And then plus, this is the first term. This is r equals 1. And then the next one would be 3 plus 5 lots of 2. Plus 2 to the power of 2. And then plus all the way up until the 16th term, yeah? So I'm going to put this here. 3 plus 5 lots of 3 plus 2 lots, 2 to the power of 3. Sorry, not 3, 16. 16, yeah? The 16th term. Okay. So looking at this here, now I've expanded it, I've broken it out, I've put it all out. Now what I can see here, right, I'm going to put these in brackets like this here. I've got this in the chat. Can you split into sum of 3? Yeah, that's exactly what I'm going to do. So yeah, I've got a couple of messages from the chat, which is good to see. So I'm just going to split like this here. Now remember, this is what you're doing. You're adding this all the way 16 times. Now, when I'm looking at this, for me, the most glaring thing that I can see from this summation here is that I have a constant 3 everywhere, right? Do we agree with that, guys? Right? So what I'm going to do is I'm going to break it down bit by bit, yeah? Now, the first thing I can see, as I said, this 3 is constant in each of the 16 different terms, in each of the 16 different brackets. So for me, all that is that just means that I have 16 lots of 3, don't I? So for this green 3 here, this will just be 3 lots of 16. And this is equal to 48. Yeah. So that's the first one done. Yeah. Okay. Now I'm going to look at the second part. The second part. Now, although it looks similar, right? It's not exactly the same because the number is changing each time. It's 5 lots of 1. Then 5 lots of 2, then 5 lots of 3, all the way to 5 lots of 16. So I can't do the exact same thing. However, it's very, very similar though. And what I would do, just to make sure I understand what's going on here, is I would break it down. I would just dissect that part on its own. So that becomes 5 lots of 1, right? Plus 5 lots of 2, plus all the way to 5 lots of 16. Yeah? Now this is just equal to 5 plus 10 plus 15, and so on and so forth. What type of sequence or series do we call this, guys? Can somebody tell me in the chat? Exactly. Thank you very much, Rene, Lulia, Daniel. It's clearly an arithmetic sequence, right? An arithmetic series. And we know that we have a couple of formulas that allows us to sum a finite amount of terms, yeah? So remember, we're summing all of these, all up until the 16th term. So I'll just write 5 lots of 16, 16 terms here, right? We're just going to use the SN formula, right? Remember the SN formula is SN is equal to n over 2, and then 2a plus n minus 1d, yeah? So I've got this here. Now remember, how many terms are there? There are 16 terms, n equals 16. The first term is clearly 5, so a is equal to 5. And then the common difference is d, which is 5 too, right? So all I'm going to do is just sum. I'm going to find S16. So it's going to be 16 over 2, and then it's going to be 2 lots of a, which is 5, plus, and then n is 16. 16 minus 1 is 15. So I have this here, and then I have d. It would work as well. So I've got a question in the chat. I'll explain it after. But for somebody that just put a message about wouldn't it work if you bring it together, you can do that as well. Yeah. So yeah, just continuing. 15 lots of d, which is 5. Yeah. So I've got this here. So what I'm going to do now is just work out what this is. So I've got this here. Get my calculator. I'm just going to put this in. So get my calculator here. This will be 16 over 2, which is 8. But because I'm in an exam, I'm just going to put it in like this. Yeah, just so I know it's all okay. 2 lots of 5, and then plus 15 lots of 5. 15 lots of 5, and then this is equal to 680. Yeah. So as you can see, what we're doing, right, is we're doing it bit by bit. We've done the green part, 48. We've done the blue part. This is equal to 680. So we've only got one more part to do. So I'm just going to write this here so far. I'm going to write answer so far. Answer is equal to the 48 plus the 680 so far. Yeah. And then all we have to do now is figure out what this is here. We've got 2 to the 1 plus 2 squared plus 2 cubed all the way to 2 to the 16. Yeah. So putting this here, I'm going to, again, write this out. It's going to be 2 to the 1 plus 2 to the 2 plus all the way to 2 to the 16. Can somebody tell me what type of series this is, please? Exactly. It's clearly a geometric sequence, for sure, right? How do we know? Because there's a common ratio of 2. We are multiplying by 2 each time to go from one term to the other, and we've got 16 terms, so we're just going to use the sum to n terms for an arithmetic sequence, right? Which is going to be a bracket 1 minus r to the n over 1 minus r, right? And we can see clearly that the first term is 2, the common ratio is also 2, and there are 16 terms, yeah? So we're just going to plug this in as 16. A is equal to 2, 1 minus r, which is also 2, to the power of 16, over 1 minus 2. Plugging this in, get the calculator. We're going to get 2 here, 2, and then 1 minus 2 to the 16, over 1 minus 2. This is equal to 131,070. Yeah, 131,070. Right? Now, what did the question ask us for? It asks for the total sum of the first 16 terms, and we've dissected it into 3 parts, right? The first part was 48, the second part was 680 there, and then the last part was 131,070. So therefore, the final answer would be equal to the 48 plus the 680 plus the 131,070. And then let me just put this, let me just double check this is all correct. Yeah, 48, 680, 131,070. So put this into my calculator now. This will give me, let me just read myself here. So because I already have that stored, I'm not going to write out again. I'm just going to do 48 plus 680 plus answer. This is equal to 131,798. And that's exactly what they wanted us to show, isn't it? So let me just double check. Perfect. Perfect. Does that make sense, guys? We all okay with this? And I got a message. Somebody said, couldn't you have, would it work if I split into 3 plus 5r and then 2 to the r? Yeah, exactly. So that's a very good question. Yeah. So remember, what you could have done too is you could have actually brought these together as well. Because at the end of the day, this is still an arithmetic sequence, isn't it? Because it's still going up in 5s, and we have that constant term of 3 each time. So it's still an arithmetic sequence. So you could have done that. That's even quicker as well. But when I'm doing these questions, I like to break it down. I like to dissect it just so I can see exactly what's going on. Yeah. Just see in the chat. Just see the chat. Okay. Good stuff. Good stuff. Brilliant. Brilliant. What is D in the arithmetic sequence? D is the common difference, right? It's how you go from one term to the other in an arithmetic sequence. You add the same term each time. In this case, it was 5. So D is equal to 5. Yeah? Okay. So we've done that. Now let's continue with part II. Now this is one of those recurrence relation types of questions. So I want you guys to tell me in the chat, looking at this one, how do we find these types of questions when we see them? Put a 0 if, listen, don't like these questions at all, hate them. Put a 10 if these are super easy. I can't wait to see this if it comes up on Tuesday. I want you guys to all give me a number. I can see 7s, I can see 10s, 9s, good. I can see a couple 4s. Okay. I can see a 2, no problem, no problem. All right. So let's go through this. Now remember, when you're doing these types of questions, right, you're looking for patterns. This is a game, right? If you see this question on Tuesday, you're going to think to yourself, this is fun. I'm looking for patterns here. Let's go through it. So it says a sequence U1, U2, U3 is defined by UN plus 1 is equal to 1 over UN, and U1 is equal to 2/3. Find the exact value of the sum of r equals 1 to 100. So we know what that means. That's just the first 100 terms. So what I would do is, okay, well, I've got this recurrence relation here. They've given me an initial value U1. Well, let me find out what U2 is. well, okay, I know that U1, hold on, let's get my pen. I know that U1 is equal to 2 over 3. And U2, in this case, will equal 1 over U1. And that will just be 1 over 2/3. And that's just very simple. That's just the reciprocal, which is 3 over 2. So therefore, I can say, well, I'm going to say, well, so far, sum of 100s to R equals 1 is UR. And then this is going to be U1, which is 2/3, right? And then plus 3 over 2. And then, well, what would U3 be? Well, what's happening? If I get U3, this is going to be equal to 1 over U2. U2 was 3 over 2. So I'm going to be doing 1 over 3 over 2. And this gets me back to 2/3, right? So what's happening here? The sequence or the series is alternating, isn't it, right? It starts off at 2/3, then it goes to 3 over 2, then we'll go to 2/3 again, and then it will be 3 over 2, and so on and so forth, right? Okay. Now, I've got a couple of questions for you guys. Now, we call this type of sequence or series, right? There's a special name for it. The word I'm looking for begins with a P. Can somebody tell me, please, what word I'm looking for? Easy, easy. You guys are gonna smash it. I didn't even finish the sentence. Thank you very much, everyone. It's periodic, exactly. What does that mean? It means that it repeats itself after a certain amount of terms. We can see that happens here, right? It's repeating after every 2 terms. Now, there's another thing when you're dealing with periodic sequences, right? There's a something called an order. Do we know what that means when they ask us for an order of a periodic sequence? If so, can somebody tell me what is the order? Exactly. It's 2. Thank you very much, Georgie, Ishmael, Ibra. Fantastic. It has an order of 2 because there are only 2 terms. There are 2 terms, only 2 distinct terms, and they repeat. Okay. Now, obviously, in an exam, after how many? Yeah, good stuff. Obviously, in an exam, it's 3 marks. They're not expecting us to add this 100 times. As I said, this is a game. You're looking for patterns here, right? So we know we've got 100 terms here, and we know that it repeats after every 2. So for me, looking at this, I can say, well, this is 2 terms here, right? Yeah. This is another 2 terms here, right? And so on and so forth. Now, remember, there are 100 terms here. There are 100 terms here. So how would I work this out? Well, you ask yourself, how many times is 2 going to go into 100? It must go in 50 times. So that means this thing in blue here will happen 50 times over the course of 100 different terms, for sure. So the answer to the question would just be 50 lots of 2 over 3 plus 3 over 2. Right? So we put this into our calculator. I'm just checking. Yeah, exactly. Well done. Well done. So yeah, let me just calculate this. And then let's continue. So it's going to be 50 lots of bracket, and then 2/3 plus 3 over 2 plus 3 over 2. And then this gives me 325 over 3. Yeah, so this is our answer, 325 over 3. Now, for those of us that were a bit stuck in this one, does this make sense? I just want to make sure we're all okay. Yeah, good stuff. Good stuff. Okay. Now I've got a question here. It says, why can't you use the sum of a geometric sequence? Well, what is a geometric sequence? Always think to yourself, what is the definition of a geometric sequence? Each term, right? E dot G, each term goes up by the same amount or goes down, right? We have a common ratio. So for example, I'll times by 2, this will give me 4, and so on and so forth. Yeah. Now you've got to be careful here, because although the terms are alternating, right? And there is a connection because it's the reciprocal, it's not actually geometric. Because if you think about it, if I start off at 2/3, right? Well, what do I multiply? What do I multiply to get to 3 over 2? Because that's the next one, right? I would have to multiply by the reciprocal, isn't it? Right? And then if I do it again, it will be the reciprocal of that. So it's not actually geometric. Does that make sense? So to make sure we're all okay with that. Yeah? Is it okay if part II has nothing to do with the first part? Do you mean in terms of doing this one? You can do this one without doing part A if that's what you're asking. But yeah, so just be aware of that. Be very careful, right? the terms are not multiplying by the same amount each time. So it's not geometric, even though it looks like it. Yeah. Okay. Now, very, very quickly, what I want to do is, because this is a kind of a straightforward question, right? Now, I'm going to ask you a question. I want you guys to let me know in the chat what you think the answer is. Okay. So imagine that they did not ask us this sum to 100, right? So all of this working out that I've done, they didn't ask. Imagine they said, for example, imagine they said the sum of 100, sorry, not 100. Let's say, for example, 107, R equals 1, U R. What are your thoughts on that? I'll give you about 30 seconds to a minute. I want you guys to let me know what you think that would be. The sum of 107 terms. Is that possible? Remember how we did this one? It was an even number. This is odd. So is it confusing? Is it possible to do? What do we do? Easy, easy. Well done. Well done. Exactly, exactly. You ask yourself, well, there's two distinct terms. How many times does 2 go into 107? It goes in 53 times and one remainder. So all you would do here is you would just say, well, it would be 53 lots of those 2/3 plus 3/2s, right? And then this is to 106. And then you would just add on the next term, which is 2/3 like this. That's all you would do. Yeah. So just be aware of that. That can come up as well. So all I would do is we'll say, well, what's 53 lots of that? 689/6. And then I'll add on 2/3, wouldn't I? Yeah. 231/2. Yeah. Does that make sense, guys? So make sure we're all okay with that. Yeah. Good stuff. So just be aware of that. Even though the summation is not a nice number, it may not go inside in the actual number. That doesn't mean all hope is lost. You can do it. You just need to be looking very, very carefully. Yeah. All right. Cool. So we've done that one. Why add the 2/3 at the end? Because remember, 2/3, right? 2/3 is the next term. Remember, if I go from 1 to 107, that means I'm summing the first 53 lots of 2/3 plus 3/2s. And I need one more to get the 107, because this right here, right? This right here is from R equals 1 to R equals 106, isn't it? Yeah. And then the next term would be 2/3. Yeah. Okay. Cool. So let's continue. Just make sure you guys did all of that. Okay. So we've done that one. That's good. Now let's go into another one. Okay. Now, proof by contradiction. Proof by contradiction. I know that didn't come up on Tuesday for Edexcel. How do we feel about proof by contradiction, guys? Put a 0 if, listen, don't like proof by contradiction, hate it. Put a 10 if this is super easy. I can't wait for this to come up. I know I'm going to get full marks. I can see 0s, I can see 6s, 7s, 5s. Rip that page out the exam. Trust me, guys, this is easy. Trust me. Let's go through it. Yeah. Okay. So it says, given that m cubed plus 5 is odd, use proof by contradiction to show using algebra that m is even. Now, remember, we know how proof by contradiction works. They give us some statement and we need to assume the opposite, the contrary to what actually is there. And we use algebra, we fiddle around with it, and we hope to get some sort of contradiction. Yeah. Now, for me, the way I look at these questions, right, is this part here. It says, given that m cubed is odd, right? This here is a fact, right? This here is a fact. This is not up for debate because it says given that, right? M cubed plus 5 is odd is a fact. Yeah. It says use proof by contradiction to show using algebra that m is even. So what we do know from this question is that m cubed plus 5 is odd and m is even for that to happen. Yeah. We need to prove that using proof by contradiction. So how do we do that though? Okay. I'm just letting a few more people in. Okay. So what I would do with something like this, I would just, m cubed plus 5 is odd, right? Is equal to odd. And we know that we need to prove using algebra that m is even. So I know for sure that m is even, right? Now remember, if we're using proof by contradiction, we need to assume the opposite. So again, That there is the fact. M cubed plus 5 is odd is a fact. Today is the 10th of June 2023. That is also a fact. That is not up for debate. The same way M cubed plus 5 is odd is also not up for debate. What is potentially up for debate is what M could be, right? How we get M. Now, they've told us that we need to prove that M is even. Well, if we're using proof by contradiction, what do we assume M must be when we're doing proof by contradiction, guys? Can somebody tell me? Exactly. Exactly. We have to assume the opposite. We have to assume M is odd, right? So the first thing you're going to say is assume M is odd, right? Assume M is odd. Yeah. Now, if M is odd, then we need an expression for an odd number. Can somebody quickly tell me an expression for an odd number, please? Easy. Thank you very much, Ethan. 2m plus 1, 2k plus 1, blah, 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 2m plus 1, whatever variable you want to use. Fact of the matter is, it's an even number plus 1. I'm going to use n. Yeah? 2m plus 1. Let me write m first, actually, to be fair. Yeah? M is equal to 2m plus 1. All right. Now, remember when you're doing proof by contradiction, what you want to do is have in mind where you want to get to. Remember, you're looking for a contradiction. So what you're going to do is you're going to plug in m is 2m plus 1 into this, right? 2m plus 1 cubed plus 5. Yeah. Now remember, this here, I'm going to write in big. This is a fact. Remember, it's a fact. I was born on the 7th of August, 1996. That is a fact. It's not up for debate. So when I'm about to do this algebra, guys, and I remember I'm looking for a contradiction. We know that m cubed plus 5 is odd is a fact. What should I expect to get out? M cubed plus 5 is? Exactly. Thank you very much, Lilia. Oliver, we should expect to get up it's even because that would contradict this factual statement here. So always have this in mind when you're doing these types of questions. Think about where you want to get to, what you should try and do. Yeah, so let's continue. So now we've got this here. We've got 2m plus 1, and then I'm going to just say this is 2m plus 1 all squared plus 5. I'm going to expand this very quickly. This one here, you expand the first time, this will be 4n squared. And then you do 2n times 1 times that by 2. This will be 4n, and this will be plus 1. And then that will be 2n plus 1, isn't it? Yeah. Plus 5. That's correct, right? Someone let me know in the chat. That's correct, isn't it? Yeah, that's fine. All right. Now continuing. We're going to expand this out. We're going to get 2n times 4n is 8n cubed for sure. And then we're going to do 2n times 4n, which is going to be 8n squared. And then it's going to be that plus 2n. That's fine. And then this is going to be plus 4n squared plus, what's that? 4n plus 1. Oh, yeah, it's just the same thing. Plus 5. Okay. Now we tidy this up. So there's only one cubed term. So I'm going to write that there, n cubed. And then how many squares? We've got 8 plus 4. This is going to be 12n squared. And then we're going to have n's, 6 n's. And then 1 plus 5 is 6, right? Okay, so I've got this here. Now remember what we're looking for. We're looking for this being even because that would contradict our statement. So if I take out, remember what I'm going to do is these are all even terms. I'm going to take out a 2. Exactly. We take out a 2 and this will give us what? 4n cubed plus, what's that? 6n squared. That's fine. And then plus 3n plus 3. Is that correct? I feel like I can't expand today. Or factorize. Yeah, that's fine, isn't it? Yeah. And what is this? Yeah. This is 2 times an integer, right? Because think about it. N is an integer. If I plug a value of n into all of this, I would get an integer out. So this is 2 times an integer, which we know means that this is an even number. Now you say, hold on, what's going on here? The fact of the matter is that n cubed plus 5 is odd. This is a fact. This is not up for debate. But we've somehow got to that same thing being even. So you say this here, this is a contradiction, right? Since we know m cubed plus 5 is odd, right? This can't be possible because this is the fact of the matter. And somehow we've contradicted that fact. It's even. So then what do you say? Well, how did we get this? Yeah. Well, we got this by plugging in m. We assumed, remember, that m was odd, right? So if we assumed m is odd and we got to this contradiction, right, then it can't work for odd numbers. What does that mean? It must mean that m must be even, proving our statement. So now you get here, this is a contradiction since m cubed plus 5 is odd. Now you say, therefore, and then what you always do to finish off, you always write the question, yeah? You always write the question, yeah? So all you do is this, you would say, given that m cubed plus 5 is odd, yeah? Let me just put this else up. Let me just get this up here. So this is how you always conclude a proof by contradiction. You always write a statement, don't you? Yeah? So write this here. This is what you'd write. Put this here. Given that m cubed plus 5 is odd, right? M must be even. Yeah? Write this here. M must be even. Does that make sense, guys? Yeah? Always write that last statement. You have to write it. We're not in GCSE anymore. The examiner needs to know that. The examiner needs to know that you understand what's going on here. Yeah, you need that concluding statement. Good stuff. Conclusion again. How do you know when to factorize? Well, remember when you're dealing with proofs. Remember what we were looking for. We were looking for an even number. We know that an even number is 2 times an integer. So if you've got an expression which you can take out a two from, then that's when you know to factorize. If you're looking for an even number. Yeah. Usually 4 marks for contradiction. Yeah, we are just using the question. Yeah. Good stuff. Cool. So yeah, I'll do infinite primes. That's a good one. I'll maybe do that. I'll maybe do a video on that on YouTube for sure. But yeah, I think that's all okay. How much time has it been? Let me just check. Okay, cool. Half an hour. That's not too bad. All right. Now let's go to the next one. Now, what's the next one we're gonna do? We're gonna do this one here. Now we've got trig. So let's look at this one. And then see. So we got this one here. I've got square root 2. Okay. I've got a couple of requests about different proof questions. What I'll do is I'll maybe try and do some on YouTube and put it up. Yeah, for sure. But yeah, just let me know and you can drop me a message after as well. No problem. But anyways, got this here. It says proof cos of 3 theta over sine theta plus sine 3 theta over cos theta is equal to 2 cot 2 theta for 4 marks. Now, show that questions. How do we find show that questions? Put a 0 if no clue, don't like them at all, and put a 10 is if I like show that questions. I love them. I can't wait for this to come up. I know my trig identity so well. They can throw anything at me. I'm ready. How do we all feel? Let's see. I can see 10s, I can see 7s, 6s, 7s, 9s. Good. Overall, good. Because we know for a fact this is going to come up for sure. Yeah? All right. Now, looking at this one here, it says we need to show that the left-hand side is equal to 2 cot 2 theta. So whenever I'm doing show that questions, the way I like to look at them is, okay, well, what is it that they're trying to get me to show? I've got 2 cot 2 theta, right? So the main thing here is that I've got cot theta, basically. So for me, I ask myself, well, what do I know cot theta is equal to? Can somebody tell me in the chat, please, our reciprocal functions? What is cot theta the same as? Right. Thank you very much, Oliver, Kylam, good stuff. 1 over tan. Yeah. Now, is there another way of writing it? Is it only 1 over tan? Exactly. So there's 2 versions because remember, we know that tan is sine over cos. So I can also write this as 1 over sine over cosine, and this flips over to cos over sine. Yeah. So there are 2 versions of cot theta for sure. Now, for me, I know that I need to get there. I have 2 options. Let me zoom out so you can see in the entire thing. Yeah. So when I'm looking at these questions, in my head, I'm in an exam. This is very quick. I have 2 options to start with. I can either try and get tan thetas, or I can either get cosine and sine thetas. Now, looking on the left-hand side, which one is it that we pick? Do we try and get everything in terms of tan, or do we use cosine and sine? Exactly. So that's what you're going to do. Exactly. Because on the left-hand side, right, what that means, sorry, I'm seeing messages and I'm speaking at the same time. Okay, I'll answer that question in a second. But yeah, we've got cosines and sines on the left-hand side. So all that means for me is that I'm going to try and use cosines and sines. Yeah. Now somebody asked, what does the big Z mean? This big Z here is just it's just a set of numbers and it's the integers. Yeah. So -1, -2, -3, -4, 0, 1, 2, 3, 4. Big Z is just integers. Yeah. Okay. It's just a set of integers. Anyways, now looking at this one here. Okay. Now, another thing that I can see with this question is that I've got 2 theta that I need to get to. I've got 2 theta that I need to get to, but I have 3 theta here. So what's going on here? What do I need to do? Does anybody have any suggestions as to what I do with something like this? What do I do with something like this? Easy, easy, easy. Brilliant, brilliant. Thank you very much, Kylam, Lara, Eric, Fizz, Oliver. Exactly, right? We need to break this down. We need to break this down because remember, 3 theta is the same as 2 theta plus theta, isn't it? So I can say, well, cos 3 theta is equal to cosine of 2 theta plus theta. And then sine 3 theta is the same thing. Yeah? Whoops, sorry about that. Like this here. Sine of 2 theta plus theta. Yeah? Okay. Now we've got 2 different angles here that we're adding. This is just a compound angle formula, isn't it? Right? So all you want to do is you're just going to, I'll write it out here very quickly. Cos of A plus B is equal to the cos of A, right? Cos of B plus the sine of A, sine of B. Is this correct, guys? Is that correct? Exactly. Thank you very much, guys. Remember, if it's plus when you're doing cosine, this has to be a minus. It flips over. Yeah? Good. Now, this one here, sine of A plus B, right? This is equal to sine A cos B plus cos A sine B, isn't it? Yeah? So all we're going to do, sorry, not A, B. So all we're going to do is we're going to use this. We're going to use this here and apply it to our question. And that's good because now we would have 2 thetas. And we know we need 2 thetas, right? So this is definitely on the right track. So let's go ahead and do this. Yeah, let's see. So we got this here. Okay, so it's cos 3 theta. So doing this, applying this one here, you know, I'm going to get the question for here actually again. Just 1 second. Let me run this out. I'll do this super quick because there's another one I want to do as well with you guys. All right. So put this here. Okay. Now, yeah. So what we're going to do is we're just going to apply these formulae here, put it into the formula. Yeah. Good. So, sorry, there's a fly. Just what? Apologies. Sorry, there's a fly. Just hold on. Okay, perfect. It's gone. Perfect. Okay. So, whoops, it's actually not gone. Sorry, guys, there's a fly all over my face. Anyways, let's go. Cool. So we've got this here. Got this here. Now, we've got cos of 2 theta plus theta, right? Now, to be fair, let me break it down just so it's clear, actually, just so it's clear, right? So we've got this here. And then remember, we've got cos of 2 theta plus theta, like this. So now we break this down. This is going to be cos 2 theta, cos 2 theta, cos theta, minus sine 2 theta, sine theta. Yeah? And then this is over sine theta here. And then plus, and then sine 3 theta was sine 2 theta plus theta. This is going to be here, like this. Yeah? Okay. This is going to be sine 2 theta, cos theta. And then it will be plus cos 2 theta, sine theta. Yeah? Is that okay? Sine, cos, sine. Perfect. Cool. And then this is over cos theta here. Yeah? Now, it's a show that question. Now, for me, the show that is 1 term, right? It's only 2 cot 2 theta. So for sure, I need to combine these, for sure, right? Now, if I combine these, can somebody tell me what the lowest, what would the LCM be, or the common denominator? Someone tell me in the chat. Exactly. Exactly. We just multiply them together. It will be sine theta and cos theta, isn't it? Yeah, sine theta and cos theta, like this. Now, continuing, remember, I've got sine theta here. The new denominator is sine theta times by cosine theta. So I need to multiply this term here, by cosine theta, don't I? Cosine theta, and I'm going to write this in a red bracket, like this, here. And then this is going to be cos 2 theta, cos theta, minus sine 2 theta, sine theta, like this. Yeah? And then plus, now look at this one here. This is cosine theta. The new denominator is sine theta, cos theta. So I now need to multiply this term here by sine theta, don't I? Yeah? So I'll put this in here, brackets like this. Let me just extend this a bit, like this. And then this will be sine 2 theta, cos theta, plus cos 2 theta, sine theta. Like that. We all okay with this, guys? We all okay with this just before I continue? Yeah? And I've got a couple of questions as well, don't worry. Once I finish this question, I'll go through it. But yeah. So now we've got this here. Remember, always have in mind, though, what you're trying to get to at the end of the day. When you're doing a show that question, you have a goal in mind. This 2 cot 2 theta here. So I'm going to put this here. This is what you're always going to do when you're doing show that's. Yeah? All right. So now I'm going to expand. Yeah? Let's expand. Even if I don't know what's going on here, I've got this far. Expand. Let's see what happens. So let's expand and see what happens here. I've got equals, and then if I expand this one here, now be very careful. We've got a lot of cosines here, but all you just need to remember is that this is here as cosine, this is here as cosine. I can just write this as cos 2 theta, and then bring those two in blue together, cos squared theta, like this. And then this one here, I don't have one of those, so I'm going to do minus sine 2 theta, and then it will be sine theta, cosine theta. And then it'll be plus, and then doing this one now, this will be sine 2 theta, and then it will be the same thing, isn't it? Sine theta, cosine theta. And then the last one will be plus these two here. This will be cos 2 theta. And then this will be sine squared theta, isn't it? Remember, as I said before at the very beginning, this is a sine theta here. This is also a sine theta here. I can just combine them like this. And then this is all over sine theta, cos theta for sure. Yeah. All right. Now remember your common goal. We need to get 2 cot 2 theta. Now I'm looking at this here. Can somebody tell me straight away, what do we see that will make life 100% easier for ourselves? Looking at the numerator. Easy. Thank you very much, Viz, Cody, Ibra. Exactly. The middle terms cancel out. It's the exact same thing here. We've got minus an expression plus that same expression. What do we say in an exam when we see this? We say goodbye, good riddance. Now, continuing, we've got this here. We've got now, this simplifies to cos 2 theta, cos squared theta, plus cos 2 theta, sine squared theta. All over sine theta, cos theta. What do we do here? Easy. Remember, you need, of course, this is all correct, but you know this, you guys were so quick at it because you know your identities very well. You need to know your identities well for you to be able to spot things like this. Clearly, we can see that if we take out a cos 2 theta, we're going to get cos squared plus sine squared. And this is just the first identity you were ever taught in year 12, isn't it? Right? Sine theta, cos theta, right? That there is equal to 1. This thing here in green is 1, right? So this just becomes cos 2 theta over sine theta, cos theta. Now remember at the very beginning of this question, we said we're going to try and get coses and sines because we know cot theta is cos over sine. Now this is promising because we have cos 2 theta on the numerator. So looking at this here, this is where we're at. This is what they want. Anybody have any idea what we do here? Easy. Exactly. Now, this is just the double angle formula. This is the double angle formula for sine theta, because you're looking at this and saying, well, the numerator is fine because it's cot, and I've got cos there. This here is the issue, right? So you say to yourself, okay, well, where do you see sine thetas and cos thetas? Well, we know in the double angle formula, sine 2 theta is equal to 2 sine theta cos theta. We have it without the 2. So let's just divide it by 2. Divided by 2. This is just sine theta cos theta. So therefore, this just becomes cos 2 theta over sine 2 theta divided by 2. And then now, remember, we have a fraction on the denominator. It flips over, times by the reciprocal. Cos 2 theta multiplied by 2 over sine 2 theta. And we're done. Because we've got a 2 there, perfect. And then we've got cos over sine. This is cot. So it's 2 cot 2 theta. Perfect, done. Does that make sense, guys? Should you always factorize out first to get sine squared plus cos squared, then do the double angle formula? It just depends on the question. So with this one here, it's clear to see, obviously, when you know identities well, we see cos squared and sine squares. Take out the cosine, take out the cos 2 theta, you get cos squared plus sine squared. Yeah, but you'd have to take it out first. I wouldn't skip it. It's very clear that it's just cos 2 theta, but in an exam, this is your exam, right? For every step. Yeah. Okay. What do you get marks? What to do to get marks if you don't spot the last bit? How many marks would this be? This was 4 marks. This was 4 marks, I believe. I just double check. What to do to get marks if you don't spot the last bit? I think you'd probably, if you get to this point here, maybe if you get to this point here, you didn't spot this last bit. If you didn't spot this last bit here, you'd probably get 3 out of 4, isn't it? Because obviously you need to get the final answer for the final mark. But yeah, as long as you know your formulas, one identities, you'll be fine. Yeah, cool. All right. Now this was part A. Now, well, where's part B gone? All right. Now this is 3 marks here. This is 3 marks. So let's see this one here. Hence, solve within the range of 90 and 180. That there. Now remember, when we're doing these show that questions, it's always in 2 parts. They give us some identity to show that it's equal to something very simple, right? Remember in part A, let me get this here. We were asked to prove this. Yeah, we were asked to prove this here. Let me paste this here. We were asked to prove this. Now, they say in part B, hence solve that. Now, looking at this, if I just saw this on its own, I wouldn't really like it. But it's good because we know that in part A, we know that this thing in green is equal to this thing in green. So therefore, you're just going to say, well, that's just 2 cot 2 theta is equal to 4. So you're solving that between 90 and 180. This is easy because we divide by 2. I've got cot 2 theta is equal to 2. Now, how do I solve that though? Because I can't see any cot buttons on my calculator. Can you? I can't see any cot buttons. What do I do? Exactly. We have to use tan. We have to reverse it, don't we? Right. So remember, if cot 2 theta is equal to 2, then let me just do it here. Remember, this is the same as 1 over tan 2 theta. Tan 2 theta is equal to 2. And if I rearrange, I'll get tan 2 theta is equal to a half or the 9. Now, you don't have to do this in the exam. You can just go straight from here and say tan 2 theta is equal to a half. I'm just doing it because I'm explaining it. Yeah, for anybody that maybe just wondered how I got there. Yeah, but you could just go straight to there. Yeah, is that clear? Yeah, exactly. Yeah. Got a question? That's exactly what you can do. You can change the range as well. So we've got tan 2 theta is equal to 1/2. Now, what I like to do with these questions here, because it's tan 2 theta, the angle is 2 theta, right? I would, or say the range is from 90 to 180 when it's theta. So if I'm looking for 2 theta, what do I do to this? What do I do to this interval? Exactly. We double it. And that tells me when I'm looking for 2 theta, it tells me, well, this will be 180, all right? This would be 2 theta. This will be 360, wouldn't it? Yeah. So that tells me when I'm looking for 2 theta, when I do the tan inverse and I get 2 theta, I know that I'm looking for angles between 180 and 360. Save time. Know where your boundaries are so you can quickly get the answer. Yeah. So now we've got tan 2 theta is equal to a half. Now remember, make sure your calculator is in degrees. If it's not, is mine? Of course it's not. Of course it's not. My calculator is always in the opposite range whenever I'm teaching degrees. And then now we're just going to do the tan inverse of what is it? Half. Like this. Like this, huh? This gives me 26.565, blah, blah, blah. So therefore that tells me that 2 theta is equal to 26 point, what is it? 565, blah, blah, blah. 56505, blah, blah, blah. Now, as I said before, when we double our range, it's between 180 and 360. So we need the next one. Now we're dealing with tan here. Can somebody remind me, please? How often does tan repeat? Thank you very much, Lilia. It repeats every 180 degrees. So what am I going to do to this one to get the next one? I'm going to add 180. So this, if I add 180, this would be 206.56505, right? 180 plus that. Yeah, that's correct. Yeah. Yeah, that's fine. And then now, let's repeat it. If I add 180 to that again, that will be 386.5605, blah, blah, blah. That's outside the range because it's 180 to 360. So the only possible answer here is this one, right? So therefore, we're going to say, well, 2 theta is equal to 206.56505, blah, blah, blah. Yeah? Okay. And then now remember, we need theta though. We need theta. So we're going to half it. Yeah? We're going to half it. And then if I put this into my calculator, so I've got that there. Let me make sure. Can you guys see my calculator? Yeah, you can. If I add 200 to this one, that will give me that number there. Note what? I need to, what's the problem there? Oh, sorry. Yeah. Thank you very much, guys. I know I made a mistake, isn't it? It should be 226. Yeah? Should be that. If I add, no, wait, let me just see. What's the issue here? No, it's fine. It's fine. No, it's fine. It's fine. It's fine. No, it's fine. It's fine. That's fine. Sorry about that. Let me minus. It would just be 206.5605. 56505. That's fine. And then I'm going to divide by 2. Yeah, that's fine. This is 103 point blah, 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 28, blah, blah, blah. Yeah. And then obviously they wanted it to one decimal place, 103.3. And that's our answer. Does that make sense, guys? We all okay with this? Yeah, good stuff. All right, let me just check the chat. Any questions on this just before we go to another one? Yeah, all good? Happy if this comes up on Tuesday, something like this? Yeah, cool. So just remember, you just need to know your identities very, very well. Yeah, for these types of questions here. Yeah, good stuff. All right. Now, you got about 10 minutes. What we can do, what we're going to do, we're going to do, we'll do this one. We may overrun slightly, but I wanted to do this one today. So something else that didn't come up is parametric, right? Parametric differentiation integration, blah, blah, blah. So got this here. Now, looking at this question, guys, what are our thoughts on it? Parametric differentiation integration, blah, 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 Cartesian. 0 if, listen, don't like this topic at all. 10 if, bring this on. Super easy. I'm ready. I want you guys to all give me a number between 0 and 10. Very mid. 0, I could do it, but it's always intimidating. Okay. All right. Cool. No, it's not. It's no questions are getting skipped. No questions like you listen, everybody here, you're gonna do all of these questions, you're gonna get 100%. 100%. Anyways, let's do this one. So the curve C shown in figure 4 has parametric equations. X equals 1 plus root 3 tan theta and y equals 5 sec theta between minus pi over 2 and pi over 2. And that's obviously in radians. So I'm going to switch my calculator up. The curve C crosses the y-axis at A and has a minimum turning point at B as shown in figure 4. So this is our diagram here. And for part A, it says find the exact coordinates of A. Okay, well, I have this graph here for part A. Now we're looking at A. Can somebody tell me, what do we know about one of the coordinates at this point? Exactly. X equals 0. Simple. Be on your way. X equals 0. 1 plus root 3 tan theta is equal to 0, isn't it? Because that's what X is defined as right here, right? We solve this. Well, this will just give us tan theta, right? Will equal, we minus the 1, we divide by the root 3. So therefore, we just need theta. So we're just going to get this here. So let me get my calculator now. And I need to change my calculator mode into to radians now. And then it will be tan inverse of that. Tan inverse of minus 1 over root 3 this gives us minus pi over 6. So what does that tell us? That tells us that parametrically, right, this value, this coordinate here is for t, or sorry, not t, because it's actually theta. Theta is minus pi over 6, yeah? So if we want the y coordinate, right? Well, we know the x coordinate is 0 for sure, because it's through the y-axis, right? To get the x coordinate, to get the y coordinate, sorry, we're just going to plug in minus pi over 6 into y, aren't we? Y is equal to 5 sec theta, which we know is 5 over cos theta. So we're just going to plug in pi over 6 into there, aren't we? So doing this here will be 5 cosine of minus pi over 6. So if I put this into my calculator, let me just make sure you guys can see my calculator. Yeah, you can soon. So it'll be 5 over cosine of minus, actually, I've got that already stored, so I don't even need to do that. It gives me 10 root 3 over 3. 10 root 3 over 3. So that is the coordinates of A. We all okay? We all okay with that, guys? Yeah? Good stuff. Oh, yeah. Also, yeah. Well done. Yeah. For sure. For sure. I've seen, but is it in the range? Yeah. Thank you very much for that. Remember, when you're doing theta, especially, it's trigonometry. Make sure minus pi over 6 is in the range, or any value of theta. My pi over 6 is smaller than pi over 2. So it is. But thank you very much for that, guys. Remember, when I'm doing these questions, right, in my head, I'm doing it in exam conditions as well. So if there's anything I miss out, even if it's basic, let me know. Thank you very much for that. Yeah. All right. Cool. Cool. So got this here. Now it says, show that dy dx is equal to lambda sine theta, given the exact value of the constant lambda. Okay. Well, dy dx, and we're dealing with parametric equations. This is easy. This is just the chain rule, right? It's dy over d theta multiplied by d theta over dx, right? But more nicely, you can just write it like this: dy over d theta divided by dx over d theta. I always use the second version. It's just quick. Find out derivative of y, find out derivative of x, put them over each other, blah, blah, blah. Yeah? All right. Now, we need to just differentiate then, don't we? So we've got this here. I'll do it in part B. We got x is equal to 1 plus root 3 tan theta. Yeah? Dx d theta. Can somebody tell me what this is, please? I know that one differentiates to nothing. Can somebody tell me what this? Oh, sorry. Why did I put one then? Yeah. Can somebody tell me? Do we remember our derivatives? Exactly. Exactly. Thank you very much, Oliver, Eric, Ibra. Exactly. We know that tan differentiates to sec squared, right? So it should be root 3 sec squared. Like that. Yeah. Sec squared theta. Perfect. Now, we've got y was equal to, what was y again? That was a 5 sec theta. Can somebody tell me the derivative of that then? Do we know, how well do we know our reciprocal derivatives? Good, 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 good. It is, so yeah, it's sec tan, yeah? It's sec tan. I'm definitely not asking you because it's not like I don't remember. No, I'm joking, I remember, don't worry. But yeah, it's sec tan. I've got a question. Is this in the formula book? It is in the formula book, but when you're doing with these questions, right? Just remember to try and memorize as much as you can, just so you use the formula book as just as a what's the word I'm looking for, just as a verification, yeah. But don't rely too much on the formula book. But to be fair, there are some standard integrals and derivatives that maybe even I don't even know off the top of my head. Then you can look at the formula book, yeah. Okay. So now we've got this here. We'll let dy dx is equal to dy by d theta, which is 5 sec theta tan theta, and then divided by dx d theta, which is root 3 sec squared theta, right? And remember, it's a show that question. Always have in mind what they want you to show. Apparently, dy dx is lambda sine theta, where lambda is some constant. So this is looking promising because, well, what do I have here? Well, I've got 5 over root 3. I've got 1 sec on the top, 2 on the bottom. So that means it will just be like this, isn't it? To be fair, it will be tan theta here and then sec theta, right? And apparently this is yeah. So somebody just put something about tan, but I'll do that. I'll explain that in a sec. But yeah, Got this here. Now remember, they want sine theta, and we're here. What do we do here, guys? How do we do this? Because we can't get here and think, okay, all hope is lost. Exactly. We're using our identities. This is why you need to know your identities very well. They come up in all parts of A-level maths, parametric equations, parametric integration, show that questions. They come up everywhere. You need to know them so well, because what we have here, we have 5√3, right? Tan theta. Now this sec is on the bottom. So it's 1 over sec, right? Which is 1 over cos. That flips straight to cos, doesn't it? Yeah. So this is tan theta, cos theta. And then remember, we know that tan theta is sine over cos. Sine over cos. And then we've got cos. Cancel. Perfect. We're done. 5√3 sine theta. So therefore, remember, we went in this form. Lambda is clearly 5√3. 5 over √3, sorry. Yeah. Does that make sense, guys? Is that all clear? Anybody have any questions on that just before we continue? Yeah. Good stuff. All right. Now, we've got 2 more parts. Oh, yeah. Alex put in the chat, even if you didn't know tan theta, right, you can use the quotient rule to differentiate it, because remember, tan theta is equal to sine over cosine. You use the quotient rule. U is sine, V is cosine, VU dash minus UV dash over V squared, blah, blah, blah. But that's long. Remember it, because why would you do that? You don't need, unless they say show that using the quotient rule, tan is equal to sec squared. There's no need to do this. Remember it. Yeah. Okay. Cool. Okay. You don't need to rationalize the denominator, do you? No, you don't. Unless they, to be fair, I checked the mark scheme for this. They didn't rationalize it. But what I would say, to be fair, if I'm in an exam, listen, this is my university grade on the line, I would rationalize it. Just put in your calculator 5√3, 5 over √3. What is that? 5√3 over 3? No? Let me just check. 5 over √3. Yeah, 5√3 over 3. Doesn't matter though. Yeah. Either one is fine. Yeah. They won't penalize you for that. Anyways, part C says find the coordinates of B. Find the coordinates of B. So where's B? Okay. Well, remember, we're looking at B here. We're looking for this coordinates of B here. Yeah. Now, what do we know about B? They told us it's a minimum turning point for sure. So what does that tell us? Exactly. See, you guys, what are you guys talking about? You guys are nervous. You guys are telling me all the answers. dy dx equals 0 for sure. It's a turning point, right? The tangent line is horizontal. Dy dx is equal to 0. So we know what dy dx is in part B, right? So therefore, I'm going to say for part C here, find B. No, I'm going to get this diagram here one more time, actually. I'll put this here. Get this out and put this down, just so we've got something to visualize when we're doing it. Okay, so yeah, we know that dy dx equals 0 at that point, and we know that dy dx, find dy dx is equal to 0. Sorry for my handwriting, but yeah, dy dx was what was it? 5 over √3 sine theta. So 5 over √3 sine theta, right, is equal to 0. Now, if I divide by this constant here, if I divide both sides by this constant, it will disappear, and it'll just be sine theta is equal to 0, right? Where theta is equal to 0. Yeah. Always remember when you're dealing with parametric equations, just be aware of your range. Is 0 within minus pi over 2 and pi over 2? It is indeed. So this is fine. Yeah. So we know that theta is equal to 0 there. So now how do we find the coordinates? Remember, when you're dealing with parametric equations, x and y are defined by a parameter theta or t, whatever they use, right? So to find any coordinates, you have to find the corresponding value of theta at that point. Yeah. So all we're going to do now is we're just going to plug in theta equals 0. Yeah. Theta is equal to 0 into both of these. If I have x is equal to 1 plus the √3 of tan of 0, I know the tan of 0 is 0. This is just going to be x equals 1 for sure. And the theta is equal to 0 here as well. This will be 5 sec of 0, which is 5 over cosine of 0. I know the cosine of 0 is 1 because it starts at 1. This is just 5 over 1, which is 5. Yeah? So y is equal to 5. So the coordinates of B are 1, 5. Does that make sense, guys? Yeah? Okay. If it wasn't in the range, do you then go and find the angle pairs? Yeah, exactly. If it wasn't in the range, then you'd have to go just with it's an equation you're solving. Yeah. How do you find the right angles in a range? If it's not in the range, you look for it. Yeah. You add 180 if it's tan. You do 180 minus theta if it's sine, and so on and so forth. Yeah. Okay. Good. And also as well, remember when you're doing these questions, right? Whenever you're doing these questions, remember what was A again? A was 10 root 3 over 3, right? Here, 10 root 3 over 3. This was the y-intercept. And this point here apparently is 1, 5. So we would expect, right, that 5 is smaller than 10 root 3 over 3, which it is. Yeah? 10 root 3 over 3, right, is equal to 5.7. So can you see? It's actually very close. And that makes sense because the y coordinates A and B are very close together. So when you're doing this geometrically, make sure that the values you're getting are making sense. 1, 5, that does make sense because it's just a bit lower than 5.77 or 10 root 3 over 3. Does that make sense? Whenever you're doing these questions, visualize it. Make sure everything is coherent. Yeah? Yeah? Good, good. All right. We've got one more. Part. Okay. Got this here. Part D for 3 marks. So this is another thing that they can ask you. Finding Cartesian equations when you're given a parametric one. So I'm going to get the 2 parametric forms here. Like this here. Okay. So, yeah. It says show that the Cartesian equation for the curve C can be written in the form y equals k times the square root of x squared minus 2x plus 4, where k is a simplified third. So converting from parametric to Cartesian, we know it always comes up. How do we find this as a topic, guys? 0, don't like it. 10, brilliant. Bring it on. What do we think? I can see 4s, I can see 10s, I can see 0s. Okay, okay. So remember, when you're dealing with parametric equations and you are trying to convert into Cartesian, remember what the whole point of parametric equations is. You have some sort of maybe function that you can express via a third parameter. So at the very basic level, I'm just going to think of a random one. E dot G, let's say I had, I don't know. Let's say, I don't know. Let's say y, let's say, for example, x was equal to t or something, and y was equal to 1 over 1 plus t squared, right? Well, if I wanted to convert this into Cartesian form, I need to eliminate that variable t, right? Well, I can see x is t. So this thing here is t. So therefore, I have y equals 1 over 1 plus x squared. And can you see I've eliminated that third parameter t? That's all you're doing with converting from parametric to Cartesian. Obviously, it gets a bit more tricky when they involve trigonometry. What you want to do with that is you want to use your identities to somehow get equations that you can then now eliminate that third parameter theta in this case. So for me looking at this question, right? Yeah. For me looking at this question, I can see that I have tan thetas and sec thetas. And I know that whenever I'm converting from parametric to Cartesian, when it's trigonometry, I need identities. So for me looking at this question, I say, okay, well, I have a tan theta here. I have a sec theta here. Do we know any identities that connect the two together? Exactly, exactly. Thank you very much, Fizz, Lulia. The Pythagorean identity, isn't it? Right? 1 plus, oops, I need a pen. 1 plus tan squared theta, right, is equal to sec squared theta. Right? Remember, this is just from sine squared plus cos squared equals 1. You divide by cos squared all throughout and you get that. Yeah? So even if you don't remember this, it's in the formula, but you can derive it. Yeah? Okay. So this is good though, because we have tan theta there, we have sec theta there. So what I can do is maybe find expressions for tan theta in x. I know that x is equal to 1 plus root 3 tan theta. Now, if I want to get tan theta on its own, I have x minus 1 divided by root 3. This is equal to tan theta. Yeah? Now, this one here is sec theta. Yeah? Well, I know that y is equal to 5 sec theta. So therefore, if I divide both sides by 5, y over 5 is equal to sec theta. So can you see now, I have two expressions for tan and sec in terms of x and y. I can plug that into this identity, and that will eliminate theta. So if I do this here, it's going to be 1 plus tan squared, right? So this is x minus 1 because that's tan. I'm going to square this, is equal to y minus 5 squared. And can you see this now has been transformed from a parametric equation to a Cartesian one? Does that make sense? This is very important. We all okay with this? Yeah? Okay, let me just get my charger as well just before I continue. Okay, yeah, good stuff. All right. Because now, obviously, they like to make things a bit harder for us. There's a certain format that they want it in. Y is equal to that. K root blah, blah, blah. Yeah? Now, remember, to another show that question, always have in mind what they want you to show, just so you can keep track of everything. So put in this here. Put in this here. So we need that. For me, that just means make y the subject. So what I would do first is, well, if I square this, this would just be x minus 1 all squared, divided by root 3 squared is a 3. This is equal to y squared over 25. Yeah? Now, we need y on its own. So what I would do, and this has been expanded, so for sure I'm going to expand that bracket. This just expands to x squared minus 2x plus 1, doesn't it? Over 3 is equal to y squared over 25. Okay, now I don't have any fractions here, so maybe what I should do is maybe combine this and then times and see what happens. Yeah, so this here is 1. I can write this as 1 divided by 1, can't I? If I put this over one fraction, this will be a 3 here plus x squared minus 2x plus 1, and this will be over 3 for sure. Y squared over 25, and that's good because if I tidy this up here, this here, I've got 3 plus 1 is 4. I've got a 4 there. Perfect. Yeah. So tidying this up, it will be x squared minus 2x plus 4 over 3 is equal to y squared over 25. Now, times in this up, this will give me a 25 times that y squared minus, sorry, not y squared, sorry, x squared. X squared minus 22x plus 4 over 3 is equal to y squared. Yeah. Now remember, they need a constant at the front k. So that's clear to me. Let me just bring this down again one more time. For me, if I bring this down here, just to the top. Yeah, exactly. Thank you very much. Yeah. So all I'm going to do here is we'll say this is just the same as I'm going to write y squared on the left now. 25 over 3 and then x squared minus 2x plus 4. Yeah, I can write it like this, can't I? Because 25 over 3 is just a constant, I can combine them. And then now if I want to get y, I need to square root, don't I? If I square root this here, it will be all of this. 25 over 3, x squared minus 2x plus 4. And this is perfect because we're just using our third laws here. AB, square root of AB is the square root of A times the square root of B. So therefore, I can write this as the square root of root 25 over 3, and then the square root of x squared minus 2x plus 4. And then therefore, this is just going to become 5 on the top, root 3 on the bottom, isn't it? And then we have this x squared minus 2x plus 4. Let me just double check that. Yeah, that looks fine to me. Does that make sense, guys? All okay with this? Make sure we're all okay with this. Yeah, good stuff. So yeah, so that's all you're doing with these ones. Yeah, all you're doing. You just need to know your identities very well when you're dealing with converting from parametric to Cartesian, because stuff like this can happen. Yeah, cool. Sorry guys, I know these A-level questions, they take quite a bit of time, so sorry for overrunning a little bit. But how are we all feeling now? Bit more confident? Oh, what did you cover in your live stream before paper one? Would it still be useful to me? What did I cover before? I covered trig. No, I didn't. I covered differential equations. I can't remember. I covered this. It's on my YouTube channel. So yeah, it will still be useful if you want to watch it over. It's on my YouTube channel. Let me just see. Just before. Thank you so much. Okay, cool. Yeah, just before I let you guys go, I'm gonna be uploading this to my YouTube channel. So I'll just what I'm going to do, let me just share my browser so you can see. So this here is my YouTube channel. I've got a couple more classes after. So as soon as I finish my class, I finish at 4 today, this will be uploaded onto my YouTube channel. So if you want to follow, like, subscribe, you're more than welcome to. I'm going to put it in the chat just so we can all do that. And because it's going to be on YouTube, if you're watching this on YouTube, make sure you like, follow, and subscribe. Let's try and get me to 1K. But yeah, hope that was all beneficial for you guys. And tomorrow I'm going to be doing another lesson at the exact same time. Yeah. So from 12 to 1, are you guys going to join? Am I going to see you guys here tomorrow? Yeah. Is there another lesson tomorrow? Can we go through quick harmonic identities? Okay. 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 What you can do, my contact is MathsWithDan. I'm on Instagram, Twitter, Facebook, everywhere. If you have any questions, just drop it to me because it's quite a lot of you. Yeah. And there's a lot of questions. Can you post a proof for infinite primes on YT, please? Is there going to be one for stats and mechanics? There should be. There should be. When is stats and mechanics? The 28th of June. Yeah, there should be. Should be. I'll make an announcement and everything. But yeah, we'll leave it there today. Guys, keep studying hard. Keep going over questions, and I'm sure you guys will be fine. And I'm sure I'll see a lot of you tomorrow. Have a good rest of your Saturday. And yeah, this will be uploaded in a couple of hours. So take care. See you guys all soon.